on the computer. I can upload it onto the notes on, it'll be on YouTube, but I'll link it. 1 second. Okay, so Avogadro in 1811 determined that they were going to decide that 1 mole of something was going to be a certain number of particles. And the reason they did that was because atoms were so small that they couldn't talk about them really quantitatively. So he decided, so like just like one day someone decided that 1 dozen was going to mean 12 things, he decided that 1 mole was going to be called 6.02 times 10 to the 23rd things. So for example, 1 mole of carbon atoms is 6.02 times 10 to the 23rd carbon atoms. So it's a whole lot of carbon atoms. Again, they did this because atoms were really small and we wanted to be able to talk about them quantitatively. If not, we would be talking about really small numbers and it would just be kind of a pain. So this is called Avogadro's number. And the whole idea is that 1 mole of anything equals 6.02 times 10 to the 23rd of whatever that thing is. Okay. All right, I'm going to move on. So if you were to write out Avogadro's number, it would look like this, which is really difficult, which is why we love scientific notation. This is a huge number, and we're going to use it pretty often. So we're always going to write Avogadro's number in scientific notation because it makes our life easier. This is going to give you the opportunity to use that EE or EXP button a lot more often and become more comfortable with it. Okay, so again, I don't need you to write this down. Just look at this. The whole point is that 1 mole of anything is 6.02 times 10 to the 23rd of that thing. So if I told you you had a mole of donuts, oh my God, you'd have so many donuts. You'd have 6.02 times 10 to the 23rd donuts. 1 mole of water is 6.02 times 10 to the 23rd molecules, because water is a molecule, of water. 1 mole of nails is 6.02 times 10 to the 23rd nails. 1 mole of iron, Fe is iron, is 6.02 times 10 to the 23rd atoms, because this is an element, of iron. So hopefully you kind of get the point. I'm going to skip this. So here's the thing, is that we need to realize that we're going to give Avogadro's number different units based on the substance. Okay? So if something, I'm going to draw on here now. If something is an atom, it is just like a single element. So atoms are just like an element. That's the unit you would give. So for atoms, it would be like silver or gold or iron or hydrogen or lithium or any element at all. Those are going to get the unit atoms. Okay, molecules are for compounds. Now, here is how we have to be specific. It is for what are called molecular compounds. Molecular compounds are composed of non-metals only. So like H2O, non-metal, we'd call this a molecule. CO2, carbon is a nonmetal, oxygen is a nonmetal. We would call this a molecule. Now notice we can't call it an atom because these aren't single elements. So this isn't an atom. Water is a molecule. It's a compound. So we're not using the word atom because they're compounds, and specifically they're compounds with non-metals only. Just 1 second. Now for formula units, these are a little bit harder. This is something that's definitely going to be new for you. Formula units are for ionic compounds, and you go, well, what are ionic compounds? Ionic compounds are metals with nonmetals. and we call them formula units. So what is an example of an ionic compound? Well, salt, sodium chloride is. This is a metal, this is a non-metal. So we would call this guy a formula unit of sodium chloride. And guess how that is abbreviated? Okay, that is the abbreviation for formula units. So anytime you see a metal with a bunch of nonmetals or metal and nonmetal, it's called a formula unit because it's an ionic compound. And you'll learn more why of this is ionic later. It's because it has charge, but we're not going to talk about that right now. Okay? So, for example, I have copper. I'd say 1 mole of copper is 6.02 times 10 to the 23rd copper atoms because copper is just a single element. All single elements we call atoms.
Can we write that down?
I mean, you're going to have access to these notes at any time, so you probably don't need to. So 1 mole of copper would be 6.02 times 10 to the 23rd atoms of copper because copper is a single element. So next we have water. Okay, well water is H2O. This is not an atom anymore. It's not a single element. It's a compound. So then you have to go, okay, what kind of compound is it? Is it a molecular compound, meaning only nonmetals? Or is it an ionic compound, meaning metal, nonmetal? Well, hydrogen is a nonmetal, oxygen is a nonmetal, so this is a molecular compound. So we would call this a water molecule, meaning 1 mole of water is 6.02 times 10 to the 23rd molecules of water. Questions? So we're just talking about how to write the units out appropriately. Okay, so last one. Sodium chloride. Kind of look at these. So these are like, look at this is a solid. It's a salt. All ionic compounds in this class are called salts. I know that you're used to seeing sodium chloride as the only salt, but it is not the only salt that exists. It's the salt that you eat, yes, but it's not the only type of salt that exists. So sodium chloride, its formula is NaCl. This is a metal. It's an alkali metal. This is a nonmetal. It's a halogen. Metals and nonmetals are ionic. Metal, nonmetal. Ionic. Ionic gets the term formula unit. So 1 mole of sodium chloride equals 6.02 times 10 to the 23rd formula units of sodium chloride. So it's not an atom, right, because it's a compound. It can't be an atom unless it's a single element. It's not a molecule because it's not only nonmetals. It's ionic, which is metal, nonmetal, which gives us the term formula units. All right, so we're going to do some practice. I want you to fill in this chart. We're going to fill it in together, but I want you to fill in how we would justify different units. So iron is atomic because it's a single atom. It's a single element. It's an element. So what would we call it? What is its unit's name? Atom. Calcium oxide. This is metal, nonmetal. Metal, nonmetal is ionic. What is the justification? The justification is I have a metal and a nonmetal. And so what unit do we use for ionic compounds? We use the unit formula unit. Carbon tetrabromide, nonmetal, nonmetal. All nonmetal compounds are called molecular. Why? Nonmetals only. So we would call this a molecule. So I would like you to complete the rest. I'm going to give you about a minute to try to fill in the rest. Okay, so these should be your answers. Look at this is a metal and a bunch of nonmetals, nitrogen and oxygen. so that's ionic. This is a single atom, so it's an atom. And this is a metal and a nonmetal, so it's ionic, which is a formula unit. Any questions on these? We're going to start doing some math with them. Okay, so we can do grams to moles and moles to grams, but now we're going to go and use Avogadro's numbers and convert particles to moles or moles to particles because we have a conversion factor for that. Remember, 1 mole of anything is 6.02 times 10 to the 23rd of that thing. Atoms, formula units, molecules. So it says calculate the number of moles. So I want moles. And I give you atoms of zinc. So the first thing you always do in any problem in here is write out the number that I gave you. So always write that out to start your dimensional analysis. It will hopefully help you set it up. Please write your units in with it because it will help you know what has to go where. So atoms of zinc. You can at least write out what I gave you. Then you start your dimensional analysis. The thing you don't want anymore goes on the bottom. So that's atoms of zinc. And the thing you do want goes on the top. That's moles. Well, what's the conversion factor between moles and atoms? Again, the word mole has a 1 in front of it. Always right now. 1 mole of anything is 6.02 times 10 to the 23rd. Now it's atoms because zinc is an atom. It's a single element. So in your calculator, let's practice. You will take 4.5 times 10 to the 24th. So I don't know if you can see, but I'm showing this on my screen. And then divide by 6.02 times 10 to the 23rd. Now, this number right here is 3 sig figs. So your answer should be 3 sig figs. So the answer ends up being 0.7475, so it's 0.748 moles of zinc. So make sure you can do this in your calculator. If you're getting a different number, it is likely a calculator issue, and I can try to help you with that on our own time. So again, this is 3 sig figs. This is 3 sig figs. The answer was really 0.747508 something something something. So this rounds up to 0.748. Okay, let's try another one. Calculate the number of atoms in 5.86 moles of carbon. So remember, first thing you do, write out what I gave you. 5.86 moles of carbon. Set up your dimensional analysis. The thing you don't want anymore, so that's moles of carbon, go on the bottom. The thing you do want, which is atoms, goes on the top of carbon. So what is the conversion factor between moles and atoms? What word always goes, or what number always goes next to the word mole right now? What number always goes next to the word mole?
It's 1.
1. Thank you. 1. Thank you. 1 mole of carbon is how many atoms of carbon? 6.02 times 10 to the 23rd. So you take 5.86 and you multiply by 6.02 times 10 to the 23rd. Make sure you're using that EE button or the EE button for your power of 10 and or the EXP button. Or some of you have a button that looks like this. That one works also. So it's 6.02 EE 23 or EXP 23 or this button 23. And now I got, sorry, I kind of wrote right here. Let's see, how many sig figs are my answer? Well, I look at this number, 3, so my answer is 3. So the answer should be 3.53 times, remember to read your whole calculator, times 10 to the 24th atoms of carbon, right? The moles cancel and we're left with atoms of carbon. Question so far. If your power of 10 is off, it is likely because you are using your calculator buttons incorrectly. And I can help you with that separately. So let's do some more practice. 3.53 times 10 to the, oh, my bad. Sorry, that's the answer. My bad. Okay, next one. Calculate the number of moles, so I want moles, and I give you 9.22 times 10 to the 23rd atoms of iron. So the first thing you do, write out what I give you. Okay, set up your dimensional analysis. The thing you no longer want goes on the bottom, atoms of iron, that goes on the bottom. The thing you do want goes on the top, moles of iron. Then put your numbers in. The number that always goes next to the word mole is 1. 1 mole of anything is 6.02 times 10 to the 23rd atoms of iron. So this is division. This is on the top right here, and this is on the bottom. So 9.22, EE button, 23, divided by 6.02, your EE button, 23. Let's see, this is 3 sig figs, so my answer is going to be 3 sig figs. I got 1.53 moles of iron. Question so far? All right, let's try this one. Calculate the number of molecules in CO2. So notice that the unit changed, but why did the unit change? Does anybody know why the unit changed?
Because we're no longer working with elements.
Because we're no longer working with elements. Thank you. So this is a molecule. It's a nonmetal and a nonmetal. The conversion factor does not change. It's still 1 mole is 6.02 times 10 to the 23rd. We're just going to call them molecules now since this is a molecule. So 2.86 moles of carbon dioxide, a molecule of carbon dioxide. The word mole goes on the bottom because that's what I want to cancel out. And molecules go on top. So the number 1 always goes next to the word mole. 1 mole is how many molecules? 1 mole is 6.02 times 10 to the 23rd molecules. So you take and you multiply the 2.86 times 6.02 times 10 to the 23rd. And let's see, this is 3 sig figs, so my answer will be 3 sig figs. 1.72 times 10 to the 24th molecules of CO2. Moles cancel. How are we doing? Doing okay? Here's your answer. All right, this is the last one we're going to do, and then we're going to move on. So this says calculate the number of moles in 1.8 times 10 to the 23rd formula units. Uh-oh, look, it's a different one now, of potassium nitrate. So why do they call this a formula unit? Well, formula units are for ionic compounds. So potassium is a metal, and then this is a bunch of nonmetals. A bunch of nonmetals is ionic. So this is ionic, so it gets the word formula unit. The conversion factor doesn't change. I'm just calling it a formula unit because this guy is a formula unit compound. So first thing I do is write out what's given. 1.8 times 10 to the 23rd. Formula units of potassium nitrate. Start to set up your dimensional analysis. Formula units go on the bottom because I want them to cancel. Moles go on the top. 1 always goes next to the word mole. 1 mole of anything is 6.02 times 10 to the 23rd formula units. So formula units cancel. These two numbers get divided because this guy, the Avogadro's number, is in the bottom. 1.8 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Now notice, this is 2 sig figs, so your answer is going to be 2 sig figs. Now here's what's tricky. The answer is this. So 1, 2. So this is definitely going to round this up, which is going to round this up. So the answer is 0.30 moles of KNO3 with the proper number of sig figs. 2 sig figs because this is 2 sig figs. Any questions? Okay, so now that we have 2 different conversions, right? We learned how to do grams to moles and moles to grams. We did that from the periodic table. And then just now we learned how to do moles to atoms or moles to molecules or moles to formula units and then backwards as well. And if you didn't notice, both of those conversions have moles in common. So we can get from grams to moles or moles to grams using the periodic table, molar mass. Now we can get from moles to atoms or molecules or formula units here using Avogadro's number. Avogadro's number, which is 6.02 times 10 to the 23rd atoms, molecules, formula unit in every 1 mole. And then this is the number from the periodic table, grams for every 1 mole. So now what's going to happen is they're going to expect you to jump from grams to molecules or molecules to grams. And this is going to be a 2-step conversion because you cannot, there's no conversion factor that jumps you straight from grams to atoms or molecules or formula units. You'll have to work with your middleman moles to do the conversions. So you'll always have to go through moles if you want to jump around. Okay.
I just got a question.
Yeah.
Do I write this down?
Well, it's up to you to write this down, but you have all of the notes on Canvas. Every single one of these slides is available to you. Okay, so here we go. Let's look at this problem. It says calculate the number of atoms. Okay, so what we want are atoms of lead. And then they give you grams of lead. So the first thing you do doesn't change. You write down what I give you. Lead is Pb. Now, we do not have a conversion factor that takes us straight from grams to atoms. There is nothing to do that. So we're going to have to go to moles first because we can do grams to moles. And then we will do another one to get from moles to atoms. So what do? The thing you don't want goes on the bottom. Gram. This right here is molar mass. Where do you find molar mass? Anybody? Molar mass comes from the periodic table. So you go find lead. It is right here. Its molar mass is 207.2 grams for every 1 mole. So 207.2 grams for every 1 mole of lead. So my grams cancel. Now I'm at moles. Well, now that I'm at moles, I can convert between moles and atoms. I have a conversion factor for that. So what goes, so moles is on top now. So moles have to go on the bottom and atoms goes on top. What is the conversion factor between moles and atoms? 1 mole of anything is 6.02 times 10 to the 23rd atoms. So my moles cancel, and now I'm left with atoms. So again, moles is kind of like your middleman to jump you from grams to atoms or atoms to grams. You can go backwards. There's no reason you can't. So I would do 4.77 divided by 207.2 multiplied by 6.02 times 10 to the 23rd. And you get, let's see, this is 3 sig figs. So my answer is 3 sig figs. 1.39 times 10 to the 22nd. So make sure you read your whole calculator. Atoms of lead. So this was a 2-step conversion. I had to do 2 steps to get to my answer. Questions? We're going to do 2 more and then I'm going to set you free to start your homework. All right, calculate the number of molecules in 17.2 grams of benzene. So benzene's formula is C6H6. So first thing you do, now why do they call this a molecule? They call this a molecule because this is a bunch of nonmetals. So the first thing you do is write out what I give you, grams of benzene. And now I'm asking for molecules. I can only get from grams to moles. I cannot jump from grams to molecules. There's no conversion factor that does that. So grams go on the bottom, moles goes on top. Grams to moles. 1 always goes next to the word mole. And then you look up benzene, C6H6. So 12 carbons, so 12.01 times 6, plus 6 hydrogens, so 1.01 times 6. That's this guy's molar mass. So you add them all up, it's 78.12. So 12.01 times 6, because there's 6 of them, plus 1.01 times 6. 78.12 grams per 1 mole. Okay, now that I'm at moles, which is my middleman, I can get to molecules. Moles to molecules. Sorry about running out of room. 1 mole of anything is 6.02 times 10 to the 23rd molecules. Moles cancel and I'm left with molecules. So it's 17.2 divided by 78.12 times 6.2 times 10 to the 23rd. And let's see, this is 3 sig figs. So I get 1.33 times 10 to the 23rd molecules of benzene, C6H6. How are we doing? Okay, we're going to do one last one before I set you free. I'm going to skip this. Okay, so this question says calculate the mass. When you see the word mass, you need to know that it generally means grams. So they want grams. Calculate the mass. And now I'm starting you off with atoms. So they want you to jump from atoms to grams. Well, there's no conversion factor that goes from atoms to grams. You can go from atoms to moles and then go from there, but you can't just do a one jump conversion. So the first thing you do is type out what I give you, or write out what I give you. 8.32 times 10 to the 23rd atoms of tungsten. Ooh, I'm going to run out of room. So what's going to go on the bottom? Atoms is going to go on the bottom because I want it to cancel. Mole goes on the top. That's the only conversion factor I have between atoms to moles. 1 always goes next to the word mole. 1 mole of anything is how many atoms? 6.02 times 10 to the 23rd. So my atoms will cancel. Well, now I'm at moles. Sorry, I'm kind of running out of room. So what goes down here? Well, I don't want moles anymore. So moles goes on the bottom now. Grams goes on the top. The number 1 always goes next to the word mole, and tungsten is W, so what is its grams per mole? Well, that's found on the periodic table. Tungsten, where are you? Wow, I'm having a really hard time finding tungsten right now.
Number 74.
Thank you. Sorry, 183.84. So 183.84 grams per 1 mole. So my moles cancel, and now I'm left with grams. So mathematically, you're doing 8.32 times 10 to the 23rd divided by 6.02 times 10 to the 23rd and multiplied by, because this is on the top right here, 183.84. This is 3 sig figs, so my answer is going to be 3 sig figs. It is 254 grams of tungsten. So this is just like the other problem, but we went backwards. Instead of going grams to atoms, we went atoms to grams, and we rearranged the units appropriately. So for anything, you get from grams to moles or moles to grams by molar mass, periodic table. You get from moles to atoms or moles to molecules or molecules to atoms by Avogadro's number. 1 mole is 6.02 times 10 to the 23rd. Any questions?
What's the molar mass of tungsten?
It was 183.84. It's right
What
here.
was that question 1 again? Couldn't
So
see that.
180. So tungsten's right here. 183.84. I skipped over the one before this. You don't have to do the one before this.